Okay, so I'd like to go ahead and get started, but people may be joining as we go. So thanks for joining our little workshop webinar today. Sorry, my cat's meowing at me. So today we thought we'd put on a workshop to discuss designing data projects. And so part of the reason that we want to discuss this is because several programs in the Students at SC umbrella program actually revolve around working on projects that may or may not involve data. And so this is a pretty important aspect to getting a good project at the end and not just working on data analysis for the sake of data analysis. And so we're just going to review briefly just an introduction and overview of a few considerations that we think are important, as well as an introduction to our panelists today, as well as a couple of project examples that they are willing to share. And then most of the time will be spent in Q&A discussion. And so I'd like this to be kind of an interactive session. And so if you have questions along the way, feel free to go ahead and ask those. And so I'd like to just start off with a pretty relevant problem use case that we've had in the recent past. So as we all know, COVID-19, ongoing pandemic, and there were a lot of efforts to use machine learning, data science, artificial intelligence to be able to help do something about this. There were lots of dashboards created, lots of algorithms on early data sets that tried to screen whether or not patients had COVID or not, or were likely to survive COVID. And so the intent there was good, but it wasn't necessarily fully thought out in the end. So like as people are looking back at a lot of the papers and tools that were built, it seems like most of them weren't actually useful. So in reading some of these articles, there's at least one review that says that maybe 2 out of the algorithms are promising for further development and use, but none of them were fit for clinical use. And then another looked at around 415 algorithms and found that none of them were fit for clinical use. And that's hundreds of people working on hundreds of different algorithms using either the same data sets or multiple data sets, data that they've collected over time, and then not really producing anything that's useful. And so part of the reason for that is the idea that you can just kind of pull a data set and say, okay, I've got this data set that's labeled, great, let's go. Let me throw a model together just to predict, whatever the labels are. But there was a lot of bad assumptions that were made. People didn't have the right clinical or epidemiological knowledge, and they didn't realize the data was not very good. And so that sort of led to this whole outcome, right? And so while the intents were good, the lack of project design and thought around it may have contributed to it not being very useful in the end. And so to go to a project example that I think is actually really cool, so a lot of this idea behind designing a data project is to think about using your personal experiences to motivate a meaningful project. And so this is an example of someone who is actually a former student volunteer with SC, so Tyler. And so I'm sure he'd be willing to talk with you guys about some of this work that he did here. But essentially, he went to a hackathon and decided he wanted to work on designing a smartwatch app that would help his father's PTSD, and using that to imitate something service dogs were already doing, recognizing a traumatic nightmare and then nudging the person to disrupt the bad dream. And so he wanted to try to do that with a smartwatch. And so this was something that was motivated by a personal story. It used data in the end, but that wasn't the main focus of it. The main focus of it was I want to do something that will help people that experience this problem. And so also to say that like this hackathon project wasn't completely packaged at the end of the hackathon. And so, good projects can be just sort of the initial start to something that can lead to greater projects later on, rather than just analyzing some data and then being like, okay, great, this is something that I'm putting on my GitHub, and that be the end of it. And so part of what we'd like to emphasize here is, start your project by considering factors that go beyond the data set and the algorithm. So I know many of you are probably excited about working with cool data and working with exciting algorithms and that kind of thing, and that's all great. But it's important, at least for parts of at least the second phase of the data science competition and parts of other programs like Computing for Change or HPC in the City, when you're developing these projects, to think about what problem are you trying to solve and why are you trying to solve that problem? Who's going to find this useful? What will they do with the information? Will it be used to make a decision about something? Will they be able to make decisions within their own lives that will make things better? Or, thinking about those kinds of questions. And then another thing to think about is, how sure do you need to be that your results are accurate, and how are you going to measure that accuracy and deem it good enough? For something like the COVID-19 data, that's clinical data, it's going to affect patients and how patients are treated. And so you want to be really sure that what you're doing is good enough to make those decisions. And so, you want to make considerations like, is it more important to catch all the true positives than to avoid false positives? In the case of, if you're trying to detect COVID-19, would it be better to make sure that you got everyone that had COVID-19, even if it caught a few people that didn't necessarily have it, so that you could do further testing? Or is it better to not waste people's time by pulling in the false positives? And so these are the kinds of things that you should be thinking about when you're thinking about your project. And so, given that, a good approach is to just write down as many ideas as you can think of, and then once you've got your ideas, you're looking to your own community and the problems within your own community or within other communities that you're familiar with. Then track down how you'll get the right data. Why is the data useful to your problem? And can you maybe use multiple sources of data? Because there's maybe multiple data sets that could contribute to solving your problem rather than just a singular data source. And then thinking about whether or not you have enough time and resources to work on this. So most of the programs that are working on projects are 2 to 4 or 5 days. And is that enough time to really solve everything, to work on all the data across, at a global scale or anything? And so just thinking about how you can narrow that scope to fit within the time frame is good. And so thinking about things like, oh, okay, instead of looking at the whole US, maybe I'll just look at this one state or this one city, depending on what the problem that you're looking at. Maybe I'll just focus on one topic or one factor. And then, once you have all of that figured out, you might want to not start modeling right away. That could be, maybe some exploratory modeling would be good, but it's good to just go through, start exploring the data, visualizing it, seeing if it looks the way that you expect it to look, if it needs to be cleaned up, if there's missing data, that kind of thing. And so I'm sure that many of you are familiar with a lot of these basic concepts, but I just want to kind of lay these out here to reiterate how important it is to approach your projects from this angle, rather than, oh, I found this cool data set and I want to start modeling on it. Okay, so are there any questions on any of that before we go ahead and jump into just Q&A with our panelists today. Okay, if not, then I'm going to have everyone, all of our panelists introduce themselves. We can go in this order. So if you want to just state your name, what you do, more generally where you work, then that would be great. And then if you want to maybe talk briefly about a project that you're working on, or something that you've worked on in the past, to kind of share just sort of your thoughts around project design, that would be awesome too. And actually, it looks like we have a last minute panelist join us, Chris, as well. So Chris, you can go after Matt after.
Yep.
Great. Okay, Dimitri.
Kristen, can you hear me?
Yes, I can.
My video on as well? Somehow I'm not seeing that. But...
Yes, it is on.
Okay, great. Okay, I only see you and your screen, but that's okay. So
don't.
Maybe it's my own like view options or something. I don't know. That's okay. Let's see. How much time do I have for this?
Maybe just stick to a couple minutes, just kind of a brief overview, and then if anyone has more questions, we can ask more detailed questions.
Yes, it's disabled to screen share, so can you enable that?
I'll just stop sharing. Does that?
All right, I've put together a couple of slides for this, and I'll go kind of very briefly here. Let's see. Can you see my slide here?
Yes.
All right, great. Okay, then we're set. So I'm Dimitri Duplakin. Hello, everyone. So I'm a data scientist at the organization called NREL. It's a National Renewable Energy Lab in Golden, Colorado. I also work as a research assistant at the University of Utah. I've got my PhD from the University of Colorado at Boulder, here just up the road. Currently, I do data science and machine learning for energy systems, specifically the renewable energy type. And then previously, I looked at things like computer systems performance, like utilization analysis, things like that for cloud computing. Speaking of projects, I guess I have one project in mind. I guess I'll go very briefly over that. So just to be specific rather than abstract. So there's one particular project that has to do with the geothermal reservoir modeling. So there's a real system out there in Nevada where the way geothermal systems work, you have a large field or reservoir, and then you have some injection fields and you have production wells, like injection wells and production wells. And so people pump water in on one side and then get the heated water on the other side. So that's kind of the basics of that system. So the schematic of that is on the left, and then on the right is what we built for the modeling and analysis of that. So it is a real data science, machine learning type project that we do here at the lab. And I won't go in the details. There are lots of moving pieces like the surrogate model and simulation data and different ML models, things like that. But just generally speaking, I try to think conceptually here how we've moved from sort of the goals of the project to specific implementation. I think that would be useful to you guys kind of as part of this sort of this workshop. So I think it's useful to start with big questions. And of course, for this one, I wasn't among the people who applied for this project, who wrote the proposal for this project. They essentially came up with the big questions, and then I was hired to help with the implementation. But I think at the high level, it's important to think of the big questions first, and possibly come back to them frequently. Like when you work on something, don't forget your regional goals. Then, in this specific example with the geothermal project, so we thought, okay, well, can we predict performance of a geothermal power plant based on the controlled inputs? That's the example of the kind of high-level question that we came up with, and then we gave ourselves about a year to investigate this. So that was the kind of a time constraint here. Then, of course, for you guys, it'll be a lot quicker. So it'll be just a few days, but still kind of think end to end, like what are you starting with? What are you trying to get at the end? Then in the course of like digging deeper, you might want to ask more specific questions. Those will be kind of your milestones, or at least that's what we call them. So they're sort of intermediate supporting questions. Like in our case, that was like, how can we train a neural network to predict a geothermal power plant? There were a lot of hows, like, how much training we need, how much data we need, that kind of thing. And it all supports the big questions. And then later on, as we sort of convince ourselves, okay, well, this is the type of analysis we want to do, then we turn those things into like specific computational tasks. And that gets very particular. It's like we choose the specific, like machine learning architecture, we choose the amount of, we choose the type of data we use, like we come up with the evaluation metrics and things like that. So at the end, we're working on something that is fairly concise, very like actionable, and then we can keep track of them. So we have the group meetings and we just test, okay, we're done with this and we're moving on, or we need more time for it. So that's kind of the process for us. I hope this is somewhat useful, and I see some overlap with what Kristen was talking about. Again, just don't forget about big pictures, and then at the same time, work on the implementation that makes sense to, like, that follows those big pictures, the big picture questions. And then just maybe my last slide here, sort of, maybe this is obvious, maybe everyone already kind of works on this and knows about it, but it's worth maybe reiterating. So it's best to document all of your pre-processing and even early analysis steps. It's somewhere early on, it's easy to skip and just say, oh, let's move on, let's finish this and move on. But then later on, if we come back to it, and then if we didn't leave documentation behind, it becomes tricky. So for you guys, even the first iterations, first kind of tasks, it's best to keep track of what you did, how, keep the metadata, keep the versions, just keep it as organized as possible. So that'll help you. So save lots of intermediate data and results. That's another piece where it's easy to just say, oh, we can recreate this data. Well, in reality, later on, you may not have time, it'll be slow. And so just kind of, if you think that you moved from raw data to kind of an intermediate result, and if you think that's valuable, save it, keep it, version control it, things like that. So just don't skip to the next step right away. So it might help you. Version control, keep track of the data versions as well. That's useful. And then organize your notebooks. That's a lesson for myself too. Often I think my notebooks get unruly after I do sort of exploratory analysis, and then I try to kind of move on to like large scale analysis. It's easy to end up with a messy sort of disorganized notebooks. So if you can kind of do some cleanup as you go, kind of pull out the pieces that really work, those are kind of like your nuggets, like, again, document them, maybe save them elsewhere, things like that. So come up with your own practices, but organizing your notebooks is important. And then the final piece is where, again, I see some overlap with what Kristen said. Always question your findings, always ask hard questions. Does it match what I originally wanted to do? And yeah, challenge your current thinking. So with that, I can pass it to the next person, and thanks.
Thanks, Dimitri.
Hi, everyone. Can you hear me? My name's Jean.
Yep, I can hear you.
Okay. Unfortunately, I don't have a slide ready, like Dimitri, but I am ready to talk to you some ideas and hopefully to share some of my perspectives. So I'm Jing Xue. I am a staff data scientist with a Goodyear tire and rubber company. So what I do on a daily basis is to work with tire engineers and project managers to develop algorithms or solutions to help commercial fleets or consumer fleets to better monitor their vehicles. So some of the takeaways that I have from my past experience is that when you develop a model there are many ways that you can help your model to perform better using things that are outside of the model. What I mean by external to the model is that upstream of the data, can you leverage domain expertise coming off from, for example, people with knowledge in physics to help you to filter out the data, or help the model to pinpoint, for example, you're trying, so maybe to put it into context of a concrete example is, we are collecting data off of the sensors installed on the vehicles, and we want to use these high frequency vibration data to devise a algorithm that can help to predict the tire wear or the tread depth of the tires. We wanted to know, is the tire new or is the tire being worn out? If it's being worn out, we need to alert the fleet managers to let them send out technicians to prepare to park the commercial vehicle somewhere and get prepared for a tire change. So that kind of issues. So for example, upstream of the model, you're looking at high frequency data and you do not want to use any extra covariates. You only have the high frequency vibrational data. And there might be physics model that's already been studied previously, help you decide that you do not want to look at data that's passing this frequency threshold, because they already know from physics-based studies that the domains of the frequencies that matters most to tire wear are lower frequency data. So that's where you can get some help to pre-filter your data. And then thinking of how do you develop a model that's more generalizable to in practice. So thinking of this particular example, you want to have a model that you can use not only for the training vehicles, but also can be generalized to different vehicles. So that determines how you want to separate out your training and test data. You want to separate out the data by different vehicles, so you have mutually exclusive vehicles for those data in your training and test set. So that's a general way of thinking of how to develop the model to be generalizable to additional unknown vehicles. And the last thing is downstream of your model, can you do something to help improve the model performance? One thing is, if you're developing a deep learning model, for example, in this case, using the high frequency vibrational data, you're developing a deep learning model that's doing a classification job. Can you use the output probabilities to further filter out your outputs, so that you are not really relying on classification results that's coming out having a lower probability that's closing to the 50%. So that's all assist or helpers, I will call them, to help you to improve your model. And those are, I think, I consider external to whatever your machine learning model or deep learning model, that can really help you develop something that's more practical and more valuable. I think that's all I am bringing today. If you have further questions, I will be happy to answer.
Awesome. Thanks, Jing. Matt?
All right, cool. I'm next on the list, I think. So my name is Matt. I'm a senior data scientist at CarMax. My work involves appraisal algorithms. So if you want to sell your car to CarMax, whether you do it in store or through our website, information about your car will be entered into a computer, and then query some of the algorithms that I work on, and then your offer will be returned to you. In terms of like going with this theme of projects that we've worked on, I'll sort of discuss, I'll pose a problem. I can't talk about some of the solutions because what we do is confidential, but a problem that I've been dealing with for the past year and a half, which fits in very nicely with some of the stuff Kristen was talking about earlier, as well as some of the stuff Jing was talking about. And that is, as a result of COVID-19, we've had a very volatile market for used cars. obviously, stores shut down about 1.5 years ago with the initial outbreak, and that sort of, changes demand for cars and pricing for cars. But there were downstream effects as well. Notably, supply chains for the production of semiconductors have been disrupted by COVID-19. And as a result, there's a shortage of semiconductors, which has prevented car companies from creating new cars. And as a result, demand for used cars, prices for used cars have been going all over the place. And so it's been an adventure trying to manage fair offers for car and that type of environment. The one thing I really want to note is the factors that are driving these wild car prices are, the spread of COVID, regulations related to local ordinances about how many people are allowed to gather, what semiconductor supply chains look like, and how other companies are responding to that. And that's all information that you could try to model explicitly, but if you don't include that explicitly in your model, you're not going to be able to predict a priori sort of the downstream effects of it. So you have to use a lot of domain knowledge and a lot of creative approaches and understanding the limitations of your data to find ways to mitigate the effects of that volatility in sort of this crazy environment.
Thanks, Matt. Chris, if you want to go next.
Hi, I'm Chris. I'm also a senior data scientist at CarMax. I work similar to where Matt does on a different side of the organization. So I work where we acquire cars at auctions. One of my roles, one of my big data science projects I've built in the 2 years I've been here at CarMax. So I kind of speak a little bit more towards like ways to think about like building a model, how it fits in, what it looks like in development at a company. Hopefully mimicking what y'all be developing here. I think one of the things coming for cars in particular, but I think is generally applicable, is really trying to understand what you're trying to do, like as if you were a person. So if you're looking at trying to buy a car, what kind of things do you care about when you're buying a car? You want to know what kind of features are on this car. Does it have a backup camera? Does it have AC that works on it? Does it need to get fixed up or tuned up or something? And you think, okay, what would I do as a person to try and know what is on this car? If I know it has a bunch of dents and damages on it, I know, okay, I have to find somebody to fix it up. If it has one feature, it might have another feature. If it has, think of it as like Apple CarPlay, it probably also has all the other types of smartphone links. So think about like, okay, what kind of models would you kind of build to try and make this happen if you were a person? If you're trying to explain to someone else how your model works, it should kind of match up with what they would do as a person. And then even think about, as you're solving these problems, think about if you're trying to make a good car buy, you can definitely make a model, it's going to make some predictions, you're going to have some errors on top of that. You're going to make mistakes. You're going to buy a good car, we think it's a good car, but it's actually a bad car. You're not going to buy a good car to think it's a bad car. And you want to kind of think about what are those errors going to look like. If you buy a bad car, it's actually a bad car you think is a good car, it's going to cost you, you're going to lose a whole bunch of money on that car. If you miss out on one good car, there are other good cars, you won't like lose as much money on that. So your errors are going to be weighted toward one side or the other. So you want to kind of consider and think about as you're building models, how do you want to err on your errors? Do you want to fix one or the other more than you would do naturally? And I think also one thing that kind of interesting play in from building models is also something about how it gets applied if you're running models. One thing for us at CarMax, we aren't just using AI machine learning to solve problems. We also have people to help do this too. A lot of stuff gets done by people, and we use machine learning to kind of help them out. You think of, okay, if my model is kind of missing in one way or another, one of the good things for understanding your problem is to know, like, can this be filled in by a person? If it's going to kind of make one type of error, you know it's going to mess up in one direction. Can this be solved in a different way than just a machine learning problem? Or can you use your machine learning to help the people know what to do? Say, hey, we can't be confident here. Someone else can go solve this better than my computer could. So that's what I have to say here for building and designing models.
Awesome, thanks, Chris. So I'll be moderating. I've been presenting already. I should have introduced myself at the beginning, but I always do this. So I'm Kristen, and I'm a senior data scientist at Intuitive Surgical. And the problem areas that we focus on are helping surgeons improve their skill through data analytics and giving them feedback on how well they're doing. And so I think Chris touched on a good point about how there's always people somewhere in that process. And so, you know, I think I get a lot of people who think that, like, you know, we're trying to make autonomous surgical robots, or we're trying to replace surgeons, or, you know, when people think about medical AI, they think that we're trying to replace doctors to make these decisions, but really we're trying to help them make faster, more efficient decisions, or to learn faster. And so that's another thing that I think is great to think about, is like, you don't necessarily need to solve like the end all be all of the problem, but maybe, you know, how can you help people do things better? Okay, so with that being said, does anyone have any questions to start us off, or? Okay.
Yeah, well, hi.
Sure.
I have a question. I think that Dimitri said about the control version. What's your experience doing control version with notebooks?
Ooh. I think it's a little tough. So like diffs don't make any difference. Like they don't make sense anymore. But just if it's a big notebook, and if it's in the version control, I guess, you know, at least you're not losing it. At least you can go back to it. And so I think kind of basic principles apply, but it's not something I'm gonna like investigate. Oh, how is this notebook different than this other version? I just get it and kind of go by the timestamp. Maybe it is tricky. It's a good question, but do others have better thoughts?
I would say it depends on the project as to what you're kind of wanting to build in Jupyter using version control. If you're doing kind of a small scale project, it's fine to just run through, do it in Git or GitHub, and just let the pain of having those unusable diffs exist. The benefit being that you can still keep that version control, the history, the commit history is really helpful. And if you want to go back to something you were trying out as part of like your exploratory data analysis side of things, they don't lose that where you would lose it very easily in a Jupyter notebook. But like when you are doing a much bigger project, you want to kind of keep that separate, do a little bit more developed, like in standard kind of Python environment, in like VS Code or something.
I have a quick question. So once you develop a model in a notebook, what is the next step in terms of production and putting that into production within your company?
I can answer this one as well. This is the hard part, I think. Making a model like is the easiest part of the role of data science, in my personal experience and what I've seen. Like, it's easy to like build something, make it work, validate it. Like that's kind of work you're trying to do, but like a lot of the extra work is getting buy-in from the rest of the company for what you're doing. Occasionally some things are like, hey, we want to change how you're doing this part of the business. We've been doing it one way for forever, we want to do it this way. How do you get buy-in to run a test? You say, okay, if we had used this thing in the past before, we would have made this much money or saved this much time. We think it's worth trying a test. You can run some research with them to like, hey, we want to do this kind of thing. Let's walk together. I'll show you kind of how it works. Explain how the model works, like having a story to describe, like I mentioned, for how you would solve a problem as a person normally, and say, okay, I do the same thing with my computer. It does the same kind of things. It makes these decisions. It's what you would have made here on these cars or this situation here. Let's run with it. Let's try it out. And you like, there's a lot of moving parts depending on the size of your organization as to how many people have to get bought into it. And that is, I think, most of the work is on top of building the model to get that out. And then the addition of like putting it into the cloud or whatever kind of situation you use to actually run the thing. Besides, you're not going to run whatever thing at your company from a Jupyter notebook, hopefully.
Does anyone else have thoughts on putting models into production?
you're going to spend a lot of time building wrappers and Python classes that are more stable. And in a corporate setting, you're probably going to have a prod QA parity tests, where basically you have a production server, which is customer facing or whatever, your partner facing, and then you'll have a QA server, which is you own it. And if you make a change, you can monitor the differences between the QA server and the prod server and ensure parity. And so before you move whatever model over, that's sort of this and that. That's more of in a corporate setting. But yeah, you got to build a lot of wrappers. You got to check for stability. Aside from just the buy-in that Chris talked about, I think as an individual, when I've done individual data science projects, a lot of time can be spent, building the website or building the front end or making sure everything fits. And I don't know if you're asking about practical tools to use. Pickling files is great. That's a great way of storing models, and then you can unpickle the file, unpickle the model, and then run it on your server that's running your website or something like that.
I can maybe just add a brief comment. So my 2 cents here is that I've actually recently used something called TF serving, TensorFlow serving, and that seems like a pretty good way of sort of train the model, and then you put it in TF serving, and then kind of it opens like standard ports, and it has like several like APIs to it. Like there's one where it's like just send a query to it over like HTTP. You can also talk to it, I think, using something called gRPC, like Google's version of RPC, and that's faster. So anyways, I think it's in a good shape where it's sort of production quality platform for doing sort of the technical side of the project hosting.
More questions from the audience?
Yeah, I have a question for any panelist. At what point in the process do you usually have a good idea of what modeling approach you want to use?
So I think like big questions that go in are sort of like, what's the value of the project? What's the scope of the project? Sort of what are the goals of the project? So sort of like early on, you sort of have like a sense of why you're doing this. And then pretty soon after that, you sort of think about, okay, how much time am I willing to spend on this? What's an acceptable product? What is the return on investment of my time look like in terms of developing it? And then you start doing some exploratory data analysis and say, okay, like what are the returns going to look like? How much am I going to get back from it? Sort of with that setup, that kind of defines, in my mind, sort of how specific of a model I'm going to use, how much I'm going to sort of some basic modeling. I might sort of pick a model that I think works. The amount of time you spend on feature engineering is also sort of in terms of the project time. How much time do I want to dig for features is dependent on the project timeline. So I think there's the step of, I'm going to try the models that I think are going to work. Let's see what the fit looks like, and then there's the question of what's the scope of the project, what's the cost, before maybe I try to implement like some more sophisticated neural networks or some models that are going to be a lot slower to train.
So I think a lot of that also depends on how easy you're making your process so that you can try out different models. So depending on that, if you, for example, you for all the model you wanted to try, you put them into your base classes. So everything is trained and tested using the same format. So that makes it super easy to add in different models, try in different models, and compare the results of the different models really fast. So if you have that set in place, it would be even very possible to switch to a different model halfway or even late in the stage. So for example, a recent example that I experienced is that, so I've already developed the model for a project, but I recently read about a new model that I feel like is a better fit. Because the process is in place, it's super easy to switch out the model, train it and compare, see the results. and switch it in. So it really depends on how you're making it easy for you to try out different models.
Any other thoughts on this? Or
Hey, Kristen, I just had a question. So you're going to do more training, so we'll have more under, like, we'll know additional tools we can use, models, so on and so forth.
yes, so Oracle, that's hosting the competition cloud infrastructure, will have a training for us to review, so to see what they can actually use. But there is a blog post that is on the SC webpage that briefly touches on some of the available tools. And I think one of those is like AutoML, and they'll be able to deploy Jupyter notebooks and that kind of thing. So,
Okay, thank you.
yep. Okay. Any other audience questions? I have some pre-prepared questions too. If no one, and feel free to add it to the chat as well if you think of any. Okay, so I guess sort of a general question. So for everyone, what advice do you have for students who are interested in creating a project that would catch the eye of a hiring manager at your company, or just that kind of puts a project at a different level than most personal projects?
I think one of the things that I've seen from a few like personal projects on data science is really kind of the ways different, like to focus your project. One approach I think is the one kind of I wouldn't recommend is like find some problem and then use the fanciest, coolest modeling technique to solve it. And say, hey, I'm a data scientist. I have this cool project. I use this fancy technique that I don't understand really how it works. And like everyone gets confused and lost. Where I'd recommend you would do instead is think of an interesting problem that you think can be solved with machine learning in some way. It can be really boring. It can be really exciting. It can be, I did a project on picking hairstylists on Instagram to use in salons. Like, I thought that was cute and fun. You can do like a linear model, and like that is an interesting project as long as you have an interesting problem that you think machine learning has a cool solution to go solve it. Find that story first, like here's something we can solve in machine learning. Here's how it's done currently by a person. Here's how you think AI can kind of pick that to the next level and use that as your story building. And then the modeling stuff kind of follows from that. Don't put the model first, the model just comes at the end. If it ends up being a cool black box, like neural network, more power to you. If I'm using something super simple, that's just as fine.
I think building a little bit on what Chris was saying, like, I think the key skill of a data scientist is data maturity, which is sort of understanding the data and understanding, you know, what you're trying to model. When you have a project on your resume, I think the skills involved, they'll probably look at, but more than that, what you want is in an interview, something, be able to talk about the problem intelligently. They're trying to hire you because of your general data maturity skills. I think the APIs for a lot of modeling is very sophisticated. And so most people can sort of use the model, and that's not like use the most fancy data science techniques. That's not as impressive or useful as being able to intelligently have a conversation about a project that you've worked on, having been thoughtful about your decisions, and, you know, having a good understanding of the problem and, you know, the limitations of the data, or the strengths of the data, or the applications of your program.
I think those are really great comments. I can maybe just add one more thought kind of on the technical side. I think it's always useful to show the scale of the learning or analysis that you've done. I think that kind of stands out. Like, yes, there's the mission, why you did certain things, and here's how, but then the scale definitely is part of that story where it's one thing you run something on a laptop, and that's fine. Again, if you did something kind of clever, it doesn't need to be computationally intensive, and it's good. But then if at some point you got to the point where you've got a lot of data and it takes hours and days on your laptop, but then you switch to something like in the cloud or on a supercomputer or something, just really working towards that, gaining that skill, and then showing it, I think at the end will really could be your advantage when it comes down to, like, again, in interviews and job searching and whatever.
Yes, definitely. Yeah, I think all of our programs where students will be working on data focused projects have some kind of cloud component. So you all get to start working on a cloud of some sort and start gaining some of those skills if you haven't already done that before. So, great. Any more questions from the audience? I can keep going. Okay, so another general question. So what's the first thing that you do when you get a new data set to look at?
TF.columns. Just look at what's in there, right?
I was going to say the exact same thing. Look at the columns.
And then, well, okay, the trick there is actually, like, I type df.columns, see it, and then remove that cell and move on. Well, and then later I'm like, oh, well, what's in there? And then I retype that and then run it again. And so again, just print it and keep it and just kind of have it in front of you, I guess, for a while until you really memorize stuff. But yeah, like the stats, the describe function is pretty good for pandas too. So it's like, all right, it'll give you like the mean and the whatever, mean and the max and things like that. So.
And the other perspective to that question is, if there is a data owner, someone that actually is closer to data collection, it's really worth their time to have a meeting with that person and learn what exactly is in the data and what each column actually means. So that would save you a lot of time in the future when you actually work or wanted to build model of that data.
I did want to ask as well. One of the most common questions that I'm always asked by students is regarding data sets that have been put out in PDF format. So I was wondering, what are you all's go-to solutions to convert that PDF picture into actual usable data set?
I mean, the first question that comes to mind is, like, how big is the data set in PDF form? And I think if sometimes if it's just manageable to brute force record, if it's like a couple of pages, sometimes it's just easier to brute force record what's there.
Well, I think that would be a really unfortunate situation. I don't have a particular experience for that, but I've read recently that Excel has developed a tool that you can take a picture of a table and convert it to an Excel table directly. So that might be a really straightforward solution.
You can also add, like, haven't had the PDF side of things, but like a lot of times getting data from like external vendors, from even internal data, people using different things in Excel, different formats, like you're probably going to have at least one other notebook or something that is going to be just for data cleaning and data formatting before you get to your actual modeling. So you do something where you like have a notebook, like inputs ugly data in whatever format it comes in, you do some processing on it, and then you want to output that to like a CSV or a pickle or something that your actual modeling notebook, which should be like much cleaner, would actually go and run with. That's kind of a good division of notebooks. We have like lots of little notebooks is a good way to like approach this kind of problem. Don't just get one giant like 200 cell notebook that does all of the things at once. you'd be much better off having like 3 or 4 notebooks.
Thank you.
Maybe that can be a problem that is solved by a student, is importing data from PDFs. They can build a model to do it.
This idea for sure.
So someone raised their hand earlier. Was there a question from the audience?
Hello.
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 Hi,
Oh,
yeah,
my
we can hear you.
network, my network is terrible tonight. I've been having a problem after cleaning the data of facial engineering and all the steps. I've been having a problem of choosing which architecture I should use after that. Yeah, I just want to know the criteria that you take into choosing the perfect architecture for training a model.
Are you asking between like using like sklearn or something else, or what do you mean by architecture?
Yeah.
Honestly, I go with the one that I'm most used to. Kind of pick one randomly, kind of all relatively equal-ish. I mostly build out of sklearn, just a kind of easier format. And when I Google things online for how to run a data science problem, it's most likely going to be sklearn that I can follow along with someone else's like towards data science blog for how to run something, and kind of use that as a base case and then convert that over to the case that I'm trying to actually deploy for my own project. So yeah, don't be afraid to copy and paste someone else's thing that works for the problem you're trying to do, and then take that and then run with that. That is the bread and butter of data science work. But as your problem changes, let your whatever system you use is determined by the problem. Don't use the system to pick your problems. If that makes sense.
I would say to not be afraid of using new packages that you've not used before. You should really use the package that has the best fitted model for your problem. If you find out that a particular model has been proven to be most suited for your question, then whatever the package is, you should not be afraid to use it. And especially considering that many of the newer packages with models that might not be available from sklearn or more popular packages, very likely that those newer packages are actually developed in such a way that they're following the same base model as the sklearn so that they can be transferable.
Awesome, thanks.
Okay,
so
thanks, awesome. Yeah.
Cool. So we're in the last 5 minutes of this session. So maybe each person, we can go in the same order, maybe just give a final thought, final advice to students who are entering these hackathons and competitions to work on their own projects, thinking about what they should be doing, what problems they should be solving, and that kind of thing. So Dimitri, if you can start.
Those are big questions, but in any case, it feels like the right advice would be to just say, try different things. Don't don't be afraid of trying multiple things at the same time. Kind of fail early, like if something doesn't work, okay, well, you can't get this package to work, fine, kind of move on. But maybe it helps to get to the same goal using different technologies. That would be kind of cool. But as far as the selection of the project, well, that's the creative part. So again, go bold, go brave, and just try it. You can always it's good to start kind of wide and then kind of narrow it down as you go, like add the constraints and limitations and assumptions and whatnot, but at least start with something that you want to investigate.
So I'm all for trial and error. So it's be prepared to fail fast. And the other really helpful experience that I got from doing the Insight Fellowship was to take the opportunity to talk to your peers and run your ideas through peers as much as you can. Make sure that you are starting with a valid idea. It doesn't have to be super complicated, doesn't have to be having a huge scope. Have a simple question, a really defined scope would really help you to develop models based off that question.
I think keeping in mind what success looks like for the project and trying to quantify like what would a successfully accurate model be, and what would a how realistic is it to hit that target? How accurate does the model need to be to be useful, and how accurate do you need to hit that target? For example, if you're trying to predict, sports teams, that's such a noisy problem that like you're probably not going to be able to get it in a very meaningful way, as opposed to the example that Chris provided earlier with the guy's watch and nightmares, which someone who'd probably have been observing that would probably be able to identify it externally. So sort of understanding when you can, what success would look like, and whether or not success will be attainable with the model and the data that you've chosen.
Yeah, I think on top of that, kind of split my advice into two parts. The first part will be when working on your project, try and find the most minimal thing you can do to get it done. Don't get bogged down in trying to make it perfect at all. Make it like the lowest bar. You're just trying to get across, like jumping over the lowest bar possible. Make something, if it's really crappy, that's fine. Get that to run and work, fail early when you find that spot, and then later come back to fill it in and make it better. If you have a model that kind of works, but it's not that great, fine, go with it, make it work. You can always fill it out later. Don't get bogged down. And the second part of the advice, when you do get bogged down, you find they're taking like 15 minutes, half an hour to solve a problem, go ask for help. Like put like a little thought process in your head, the little flag that goes off. Like, I'm stuck looking at this thing for too long. Go try and find a way to get some kind of support. It's easy kind of trying to make this thing that doesn't exist to get stuck on one part of the problem. If you can't solve it, either you need to fail there or get help to try and find someone else to kind of get you beyond that hurdle. Maybe you don't need that part. Maybe you can go in a different direction. That'll be my advice here.
Great. That was all really awesome advice. I hope everyone has learned something today. And if there's any other questions, follow-up questions, feel free to send them through to the Slack channel. If you haven't joined the Slack channel, please accept your invitation to Slack and chat with us there, as well as if there's any other general topic areas for workshops or webinars that you're interested in that's not on our current schedule, feel free to suggest it and we'll see if we can put something together. So with that, if there's nothing else, I will let everyone go. Thanks all for joining.
Thanks all. Good luck.
Thanks, Kristen. Take care. Thank you, everyone.
Thanks.
Later.